Hello, so today we are going to do this problem, which is part of August's daily challenge, max sum of rectangle no larger than k. So basically the max sum of any subrectangle in the rectangle that we get as input that is smaller or equal to k. And we get the k value. And yeah, it's guaranteed that there is a result. And so let's take a look at this example. So if we take a look here, we want a sum that is the largest sum that is smaller or equal to 2. And this one would be 3 plus 1, 4 minus 2 is equal to 2. So yeah, that's the largest one we can have. Yeah, because it's literally equal to k. So we can't go past 2, and so we just return this. So that's the idea. Let's see how we can solve it. Yeah, so the main idea that we can use to solve this is to think about how would you solve it in an array, right? How would you solve it in just a simple array, like maybe something like this? Well, definitely you will do the prefix sum. Let's say this is a larger than this, maybe 5, 7, 9. So you'll do the prefix sum, which means basically you will just add up. So this becomes 1, 1 minus 2, minus 1, 2, 7, 14. And then if we put 9, 23, I think, or something like that. So we'll get the prefix sum, and then that way we can easily find the sum for the sub arrays. So for example, for this sum, not that one. For this here, it's easy to find the prefix. It's easy to find the sum of that one instead of having to traverse the entire thing and add it up. We can just take the boundaries here and do subtract, right? So 5 plus 3 minus 2, that's 8 minus 2, that's 6. And that's just 7 minus 1, right? So just subtract the boundaries. That will give us the sum of the subsequence. So we know that for a subarray, the solution is to create a prefix sum and then just subtract. So we can just scale that idea up to a matrix, right? And so we can calculate the prefix sum for the rows, right? So for the matrix, let's maybe take a larger one. 1, 0, 1, 2, 2 minus 1, 3, 1, 4, 5, 6, 2, 3, 1, 8, maybe 9. Okay, so it's going to be tricky if we try to do kind of the prefix sum for the subrectangles. But so let's see how we can simplify it. Instead of doing that, let's just do the prefix sum for the rows. So that's the first idea, prefix sum for rows. Which means basically this row is going to become the sum of this row plus this row. And then this row here is going to be the sum of all 3 rows. And then this row here is going to be the sum of all 4 rows, right? So that would mean basically we'll add this up. So it would be, so the first one stays as it is. But for each I, we will add up I minus 1. Right? Except of course the first row, because there is no I minus 1, right? And so that would be 3 here, minus 1, 4, 3. And then we do this, we add up to this one. So that would be 3 plus 4, 7, minus 1 plus 5, 4, 3 plus 6, 9, and then 1, 3, and then you get the idea. We'll fill this one as well. Yeah, let's actually just do it. 10, 4 plus 1, 5, 9 plus 8, 17, and then 2, 11, yeah. Yeah, so once we have the prefix sum, now how does this solve the problem? Remember, the problem is max sum smaller than or equal to k. So once we get this here, we can just take to find the prefix sum for a sub matrix, but here we have for the prefix sum, the only way we have to start from 0 row and add 0 column and end at columns minus 1. This is the length of columns. To find any from I1 to I2, so to find any sub-rectangle sum that starts from 0 to column -1, we can just take this here and subtract it from this here. So if the matrix is large, then to find the sub-rectangle starting at, let's say, row 2 and ending at row 5, then we can just take the sum in row 5 and subtract it from the sum in row 2, right? So that will cover finding the solution for just the rectangles between rows. But the problem is the largest sum may be something here, right? If, let's say, this was positive and big, and this was negative. If this was -3 and this was 9, then maybe the prefix sum, the largest rectangle would be, this was smaller, maybe 2, then the largest rectangle sum may be an inner rectangle, and so the column is not 0 to columns -1. So we need a way to handle that case. And so to do that, we can do a sub problem and solve that problem. How do we solve that? Well, we do the same thing. We accumulate each row inside each row, right? So we do the same thing we did in the array here. We do it for each row. We do it for the row, and then we binary search for the closest sum to k. And that will give us the solution. Because once we do the prefix sum, it's sorted, right? And so we just binary search for the prefix sum that will give us, that is like s minus the limit k. And s here would be just all the prefix sums for the row, right? You might say, why are we binary searching for s minus k? Because the prefix sum is p2, let's say a sum here minus p1, that's the sum for the subarray. And so s would be somewhere here, and we are looking for an x, that is, we are looking for an s minus x, so this is what we are looking for, smaller than k. Because this would mean we have the prefix, we have a subrectangle between s and x, and we are binary searching for this x. And so if we find this, so instead we don't, so we are looking for this x, so we can just change this formula to be s minus k. So we can just change this formula to be s minus k, and then just smaller than or equal. So here this means this is the same as s minus k, smaller than or equal to x. Alright, so we can just binary search for this, and once we find it, that means we found a prefix sum that is equal to the largest sum we want, right? Or not equal, but closest, right? And then each time we do it for, now the question becomes, how do we iterate for each 2 rows and then check for the sub-columns? Well, the answer is easy. So let's say we have 0, 1, 2, 3, 4, 5, right? Let's just try all 2 pairs. So we try this between 0 and 2, and then we will get we have the prefix sum to find the sub-rectangle here sum. And then we just do the prefix sum for each sub-column to check if any sub-rectangle here is the max. So we try every pair, 0, 2, we try 1, 3, we try 1, 4, we try 1, 6. And in Python, that's easy. We can just do combinations of length 2, and that way we get every 2 pairs, right? And that's pretty much the idea. So first do the prefix sum on the rows, then pick every two combination of every 2 rows, right? Get the prefix sum for the entire rectangle from 0 to columns -1 in between these 2 rows. Check if that's the max. If it is, assign it. Otherwise, the max may be in the sub matrices in between the columns, so not 0 to columns -1. So to check that, we do the prefix sum also for the columns. Inside these 2 rows. and then binary search for the closest one to k, return it, and check if it's the max. If it is, assign it, right? And that's pretty much the idea. So the main idea is prefix sum per row, by row, and then by column, and then binary search for the closest to k. Cool, so let's implement this and make sure it passes test cases. Okay, so let's write down the solution that we just saw in the overview. So the first thing we need to do is we need to do the prefix sum. So prefix sum for rows. So to do that, we need to go for, we need to have first the size. Let's just make this m to make it easier to read. And the rows, number of rows, and then number of columns. And then we do prefix sum for rows. So we start for range of rows. We need to start from 1, right? Because the first row, the sum is just the same, the values in the row. And what we want is something like this, to assign, to add to the current row the previous row values. So to do that, we just need all the columns, right? So range of columns here. And what we need to do is just do this for every column j. And so this would give us the prefix sum for rows. One thing we want to do, just to be able to have, to consider the prefix sum of just the first row, we want to add zeros. So we want to be able to add a set of zeros for as many columns as we have, so that basically, let's say if the first row in the matrix, maybe it has 9, 12, 13, like just big numbers, and the rest of the matrix is all negative. So the largest sum would be actually the first row. So to be able to consider that, because we'll take pairs of all the rows, we don't want to take 1 and 1. We want to take different values, right? And so we will append 0, 0 just so that we can start from this one. So this would be a submatrix with 2 different rows, right? So to do that, we will just have the matrix will append a list of zeros, a row of just 0 values, right? Because that won't impact the sum, right? So this in range of columns, this would be the new m plus m. And then we want to go through take every combination of 2 rows. And basically we want to, and then we want to check every sub matrix in that range of, in between these 2 rows, right? And so to do that, we'll take its 2 rows, R1 and R2, and then we'll do the combinations for the range of length of m. So this would be just the rows, range of rows. And we want to do every 2 pairs. So this is how combination function works. We need to give it the range of the numbers and then how many combinations we want. We just want 2. And now, remember, in an array, to get the prefix sum, it's just the value at, it would be at R2 minus the value at R1, right? So that's what we want. And so to do that, we just go for the zip of the 2 rows, right? So that would be R1, R2. And this will give us all the sums, the combinations of all the sums in the 2 rows, right? So that we consider all the sub, let's say this is 0 to 4, so that we can consider all the sub ones. And so here, the row would be equal to, let's initialize our row. Every time we'll just append S2 minus S1. The larger one minus the smaller one. So now that we have our row, we can actually write this slightly better. So this would be S2 minus S1, and then for both are equal to this. Okay? Okay, so now we need to do it for the sub-columns. And so to do that, let's just say column range sum, like that. And we want to give it the row that we are going to look at. And we want to give it, so this is basically gives us the values in between for that row, right? Because similar to an array, it's just this minus this gives us that subrectangle, right? And so here we get a sum here. Let's call it S, and we want to check if that's the best we have so far. And the best, we need to define it. Let's say it's just we'll start with the smallest possible number, just so that so that any value we find is better, and we want to return the best so far we find. And now we need to define this function where we said we need to do the prefix sum for the row and then binary search for the answer. And so we need we have an array, and we need, let's call it limit instead of k. And so to be able to binary search, we need a sorted list, right? So let's just have a sorted list. Let's start from 0 again, just similar to what we did here, just in case the first value in the row is the largest. Maybe this can happen if we have a row that is like 9, and then minus maybe 1, minus 2. The rest is all negative, right? So the first one is the answer. So we wanna add 0 just so that we can take care of that. Okay, so now we go through the prefix sum. So to create the prefix sum for an array, you can do it like with a for loop, where you go through every I and j index and just say prefix of I is equal to prefix of I plus prefix of I minus 1. But in Python, there is an easier way to do it, which is using accumulate. And so we'll just use that. And so we'll do, this is in Era Tools, by the way, library. And so this will give us the prefix sum. So actually, let's just call this prefix sum. And then we'll do like that. And then we need to binary search. We'll use Python's bisect left instead of writing our own. We want to binary search for this prefix sum minus the limit, which we said that will give us the x value that we are looking at, and the x would be just the other prefix sum that we need to consider, and that way to get the sum we'll just do s minus that value, right? So this would be, let's say we have maybe a prefix sum where there is an x here and there is an s here, and this sum in between the two needs to be smaller or equal to limit. And so if we binary search for s minus limit and find this x value, we know that the sum itself is just s minus x, right? So the sum here is just s minus x, and this is what we are looking for, s minus x. So this would give us the index we are looking for, so let's call it I. And if I is smaller than the length of the row, that means we have a valid solution. If it's bigger, that means we don't have a valid solution, so we don't want to do anything. And then we want to return the max of this row, right? So let's call it row range sum, actually. So best in row, let's call it. And let's call it best here. And so for the best here, what we want to do is max. We want to initialize it to some smaller value so that we can get, so we do minus infinity. And then here, and then here we want to get the best is the max of best, and the sum, remember, it's s minus x, and x here is just the value in list at position I, right? And so this would mean here we need to say s minus, let's call this x just so that it's super clear, minus x, and that will give us the sum between the two, right? So x is the sum all the way to the left up to this point, and s is all the way to the left up to this point, and so the sum of this subrectangle is just s minus x. And once we have this prefix sum, we want to add it to the sorted list so that we can binary search for it next. So we append, or actually add for sorted list, And so we add, let's add s, right? That's the prefix sum we find. And then at the end we return the best we've found so far. And that's what we return here, and we check if it's the best overall. And that's pretty much it. So let's run this. I hope this part was clear. Yeah, just write it down and try to see the different rectangles, and it should be clear there. So we need to import a couple of things. So we need to, from sorted containers, you can, of course, like, if you don't want to use sorted list, you can put all the prefix sums in an array, right? And then sort that. They are already in an array, so you can sort them if you want. And so here we want to say in sorted list. And we want to import from iteraTools, we want to import accumulate. That will create the prefix sum for us. So if we run this, import, not in. Okay, let's submit. Yeah, so the problem here is we don't want to check the length of A, right? We want to check the length of the list we are looking at, so that should be list here. Yeah, so another problem we have here is that I was using rows here, but because we added a new row, so the length is no longer this rows here, right? So we need to use a length of M. So let's actually use that everywhere so that we don't confuse ourselves. And this would be a length of M0. So let's try this again. Okay, so that passes. Let's submit. So that passes. Yeah, so the idea, prefix sum for the rows, then prefix sum for the columns, and binary search for the answer. Yeah, so that's pretty much it for this problem. Please like and subscribe. Thanks for watching, and see you on the next one. Bye.